Oftentimes in an experiment, we need a control group or we need a baseline data. What happens to these people if they're not given a treatment? What would be the response variable that was being measured? Okay. Oftentimes there will be changes even when there are no treatments being imposed. So the control group is used to determine what is the baseline, what is the status quo. And then we can see if the experimental group is different from the control group in a way that we will say later to be statistically significant. Okay. The control group is the group that receives the placebo or the dummy treatment. There's nothing in it. So say we want to determine if our new headache remedy truly works. Well, half the subjects that we randomly select would receive the drug. The other half would receive a sugar pill or a dummy pill. Therefore, we would have two groups to compare to one another. Why? Why would we need a placebo? Why would we take the time to select individuals for our experiment and then not truly give them the experiment or the explanatory variable that we're looking at? Well, there's something called the placebo effect. And what the placebo effect is that oftentimes individuals or subjects or humans will respond favorably to any treatment whatsoever because they believe that it's going to work. And the mind is a very powerful thing. In an experiment, what we're trying to do is control all of the outside variables. We're trying to control as many of the confounding variables as possible, or lurking variables, the outside ones that we're not looking at. In this case, my variable of interest is the headache remedy or the drug that I've made. I want to control anything else if possible. So the placebo effect happens when you're told, hey, you're going to get this treatment. And you say, oh, yeah, man, my headache feels way better, when really you didn't get a treatment at all. Why? Because you believed, your mind thought this is going to work. So in your brain, it did work and you felt better. So the placebo effect is the reason that we need a placebo to control that extra outside variable. In an experiment, we are trying to make it so that you cannot poke any holes. When we're done, we want to say, yep, the new drug caused your headache to go away. We're trying to make it so that it's airtight that way, which is a very, very difficult thing to do. So control in an experiment is very, very challenging. Okay. Oftentimes, just by the way that a researcher treats the subject, they will get a different response. So some experiments are designed double blind, meaning that the researcher nor the subject knows who's getting what treatment. If I'm the researcher and you're the subject, and I know that you got the drug, I might tell you, oh, you look a lot better today. Your eyes are all cleared up. You look like you're feeling a lot better, trying to get a response that's favorable to what I wanted to show. And if I know that you're getting the dummy pill, I'll say, oh man, you look like crap today. I don't think you're going to make it through the day. So a double blind would eliminate that problem in an experiment. Double blind, I wouldn't know what treatment you were getting, nor would you. There would be a third party recording. A single blind, it's just when the subject doesn't know. So if the researcher has no interaction with the subjects, then a single blind experiment would be fine. So the two different types, there could be a double blind, meaning neither the researcher nor the subjects know, and a single blind means that the subjects don't know. But double blind is the researcher nor the subjects know. So how do we conduct an experiment? If we conduct a properly designed experiment, when we're done, we can talk cause and effect. The only way to talk cause and effect in a experiment is through a properly designed experiment. Just because we notice a relationship, like we saw in chapter 3 with linear regression, just because there is a relationship doesn't mean that it's a causal relationship or that X caused Y. But if we design an experiment properly, then we can finish the experiment and say, look, X caused these changes and Y. What's super, super important to make sure we have a properly designed experiment are these next three things. I refer to them as CRR, okay, or CR squared. We need control. What do we need to control? We need to control the lurking variables. We need to control anything other than what it is that we're trying to test. So we need control. We need randomization. Okay? The subjects need to be randomly assigned to each group. And finally, we need replication. If it works once or it works twice, that doesn't prove that it's going to always work. That doesn't prove anything for us. So we need to control lurking variables. We need random assignment or random allocation, making sure that the subjects were randomly assigned to the different groups, whether it was the control group or the Excedrin group or the Tylenol group. It needs to be entirely random. And then finally, we need replication. We need to do this over and over and over and over and over again. Without many, many, many trials, we could say, well, that was just dumb luck that it happened to work this time. It worked once, doesn't mean it's always going to work. So we need control lurking variables, randomly assign the subjects to the different treatment groups, and replication, many, many, many trials.